Michio Kaku reveals why physicists talk nonsense. Mainly this is about the stereotype of the physicist versus engineers issue, which is represented as follows. From the physicist's point of view, they consider themselves superior to engineers. From the engineer's point of view, the physicists, especially the theorists, are idiots. And this is sort of the in-house squabbling that goes on between physicists and engineers. Right. This ties in to the growing group of us who claim Einstein is wrong. I'm part of this group of people who's growing in numbers who's saying Einstein is wrong. Now, we are a group mainly of engineers, and when we get to look at Einstein from our background, we say Einstein is talking nonsense, etc. And I've dealt with my videos where I've explained why Einstein is talking nonsense, and now it's going to be why the physicists think they can get away with talking nonsense. Michio Kaku is a theoretical physicist, and his little talk is the universe in a nutshell, and it's here. And of course he's talking from a position where he thinks a theoretical physicist is superior to an engineer, but he's going to explain what happens in the science education system, which creates physicists such as theorists and engineers, and how we end up as having this clash between physicists and engineers, where the physicists get this feeling of superiority, and whereas us engineers look at the physicists and think they're idiots. So this is how the education system works and why it is creating this situation. And here we go. This is the video talk, and he's just talking about dark matter and dark energy, and from that position he explains from the physics theory point of view, we don't really understand what dark matter and dark energy is. And from that saying they don't know what it is, he's then going to get onto the issue of the science education. Let's go. Let this sound a bit louder. Here we go.
So in other words, for you young aspiring physicists out there in the audience, you may be saying to yourself right now, why should I go into physics? Because you guys already have a candidate for the unified field theory, right? Just realize that every single physics textbook is wrong. Every single
physics textbook is wrong, and sort of many of the people I'm with would sort of agree with that what's being taught to physics students is wrong, but he's coming it from his particular perspective, where he's talking about the textbooks don't deal with dark energy and dark matter, and so from that point of view that needs an explanation, and the textbooks don't actually tell you about the explanation of that because they don't know at the moment. So there's something more that they need to discover in physics to be able to get the textbooks accurate. So we go back to him again saying about it, every physics textbook is wrong.
So in other words, for you young aspiring physicists out there in the audience, you may be saying to yourself right now, why should I go into physics? Because you guys already have a candidate for the unified field theory, right? Just realize that every single physics textbook is wrong. Every single physics textbook on the earth says that the universe is mainly made out of atoms, right? There it is. The universe is mainly made out of atoms. Wrong. In the last 10 years, we have come to the realization that most of the universe is dark. And there's a whole shelf full of Nobel Prizes for the young people who can figure out the secret of dark matter and dark energy.
Right, so that's what he believes, but from our perspective of people who think Einstein's wrong, the whole physics community of physics theorists have gone on a diversion set up by Einstein, and so when they're coming up with things like dark energy and dark matter, It's all a fault of them being on the wrong track.
Right? There it is. The universe is mainly made out of atoms. Wrong. In the last 10 years, we have come to the realization that most of the universe is dark. And there's a whole shelf full of Nobel Prizes for the young people who can figure out the secret of dark matter and dark energy. Let me give some advice to you. If you are a young physicist, perhaps just getting out of high school, you have dreams of being Einstein, of dreams of working on string theory and stuff like that, and then you hit freshman physics. Let me be blunt.
So, it's trying to appeal to a new audience of people to go into physics by dreaming of being the next Einstein to sort everything out. But from our perspective, the group of dissidents I'm in, physics has gone really wrong with Einstein. You need to throw out a lot of stuff which Einstein has introduced into physics to get physics back onto the right track again. And that's not the way he's wanting to think. He's thinking Einstein's a genius, bringing more people to work on what Einstein's set them to do. From our point of view, no, that's wrong. They're off on the wrong track. They've gone to dreamland. So we pick it up again.
Some advice to you. If you are a young physicist, perhaps just getting out of high school, you have dreams of being Einstein, of dreams of working on string theory and stuff like that, and then you hit freshman physics. Let me be blunt. We physicists flunk most students taking elementary physics.
So what he's really saying is the intention is to flunk most students who are going in as freshmen to do physics. They're making it really difficult at the first step, and he's going to come up with a reason why they're doing that. But it puts people off of going into physics when they're hitting the hurdle like that. You sort of like find the subject too hard and you want to give up. So it's very unfair to do that to students. So let us go back to that again. He's admitting the way their teachers are dealing with freshman physics. Shouldn't really do that.
High school, you have dreams of being Einstein, of dreams of working on string theory and stuff like that, and then you hit freshman physics. Let me be blunt. We physicists flunk most students taking elementary physics, and we're more or less encouraged to do so by the engineering department.
So they want to fail most students at freshman physics, and they're offloading the blame to the engineer department. From the engineering department, who are onto practical issues, they don't want people believing things which are nonsense. So the basic fundamentals of freshman physics should be good, which is what the engineering department wants.
We physicists flunk most students taking elementary physics, and we're more or less encouraged to do so by the engineering department. We don't want to train engineers who make bridges that fall down. We don't want to create engineers that create skyscrapers that fall over. There's a bottom line. You have to know the laws of mechanics.
So that is the bottom line. When, as a student, you enter freshman physics, you're going to be hit with a hard subject, and it's going to be the reason why is because they don't want engineers to believe things which are nonsense. So first off, they want to hit you with hard facts, and so when they train you up, if you do decide to go from that freshman physics into engineering, you've got a firm grasp of engineering mechanics, and so you're not going to do this nonsense of making skyscrapers that fall down and so forth. They want you to have a good strong grounding in the mechanics side of physics, and the mechanics side of course is Newtonian mechanics. So you're being hit straight away. You've got to have a strong understanding of Newtonian mechanics.
Train engineers who make bridges that fall down. We don't want to create engineers that create skyscrapers that fall over. There's a bottom line. You have to know the laws of mechanics. So before you can work with the laws of Einstein, you have to work with the laws of...
So you have to know the laws of Newtonian mechanics before you go on to the Einstein stuff. Now, I want to point out that those people of us who stick with Newtonian mechanics and carry on with engineering, we've got a strong grounding in engineering, and we don't want to build skyscrapers that fall down. We don't want to build bridges that fall down, and so our grounding is within Newtonian mechanics. So if we haven't gone on to then look at the Einstein stuff, but we do come back to it in our later years after having had a career in engineering, what we find is Einstein is talking a load of nonsense. So what these people are doing, people like him, they're teaching students first off Newtonian mechanics. If you want to use that and carry on in that direction, they can go into engineering and they don't build their bridges that fall down. But if they want to carry on with theoretical physics, they go on to the Einstein stuff. And we from engineering, we will look at that and say, all that Einstein stuff, that is a load of nonsense.
Friction, levers, pulleys, and gears. As a consequence, we have a very high flunk-out rate in elementary physics.
Elementary physics, you have a very high flunk-out rate, and that's basic Newtonian mechanics, Newtonian physics.
Mechanics. So before you can work with the laws of Einstein, you have to work with the laws of friction, levers, pulleys, and gears. As a consequence, we have a very high flunk-out rate in elementary physics. So if you're a young physicist graduating from high school with stars in your eyes, and you encounter freshman physics for the first time, watch out. If you have a rough time, that's the way it is. I started out my life...
That's the way it is. That is the reveal. That's the reason what's going on in physics. So if we go back to this, we have the stereotype of the physicists versus engineers. And if the engineers are being taught Newtonian mechanics, and they've got to have a strong understanding of Newtonian mechanics, so they don't build bridges that fall down, they're going to then look at Einstein stuff as being a load of nonsense, if they do actually get round to it. And so with physicists, well they had their hard time first off with Newtonian physics, then they don't have to bother about it anymore, then they go off onto their fairyland with Einstein. And so when we engineers look at them, we say, from our point of view, the physicists, especially the theorists, when they've gone off into their fairyland of Einstein, they're talking a load of nonsense. We look at what Einstein says, he's talking a load of nonsense. So I have looked at this issue, and the unified theory of Newtonian physics is Boscovich theory, and that is omitted from physics education. From my point of view, that theory makes sense, and theorists have gone wrong with Einstein. So that's what's going wrong. They're not teaching students unified theory of Newtonian physics. If I can go back, we go back to the beginning now. This is a talk about physics, and it's going to start from early on in physics, with Newtonian physics and so forth, and then I'm going to point out when he goes wrong. Unfortunately, we have to be wary of adverts, so here we go.
My name is Professor Michio Kaku. I'm a professor of theoretical physics at the City University of New York, and I specialize in something called string theory. I'm a physicist, and some people ask me the question, what has physics done for me lately? I mean, do I get better color television? Do I get better internet reception with physics? And the answer is yes. You see, physics is at the very foundation of matter and energy. We physicists invented the laser beam.
So he's going wrong now. From our point of view as engineers, we go back to this issue of the stereotype of the engineers, of the physicist versus engineers issue. From our point of view, the engineers are the ones who are doing practical things. So practical things like lasers, well, we would think an engineer would do that. We engineers think, well, that's an engineering job, that's practical. What a theorist of physics would do, they would deal with a theory of physics. They don't actually deal with practical things. Lasers is more an engineering issue. It's not a theoretical physics issue. We engineers, we make things work. We don't care so much about what the theory is. So what the theoretical physicists are doing is they're trying to understand the universe. They're coming up with theories to try to understand the universe. That's what they're trying to do, but they're not doing practical things like building lasers. That's an engineering job. You might have people who say, oh, I'm a physicist, and they're out there building different types of lasers, but that's more of an applied physics thing. That's not a theoretical physics thing. And so when you applied physics, that is more engineering. So he's falsely representing physics here. The actual creation of lasers and so forth, that is more an engineering task.
Yes. You see, physics is at the very foundation of matter and energy. We physicists invented the laser beam.
They didn't.
We invented the transistor. We helped to create the first computer. We helped to construct the internet. We wrote the World Wide Web. In addition,
We disagree with all that. It's like you either treat that is applied physics or that is engineering. It's not theoretical physics. Theoretical physics is trying to understand how the universe works. And so from a theoretical physics point of view, you are not doing practical things like that.
we also helped to invent television, radio.
Television was, I think, Yogi Bear and not Yogi, Eric Bear, I think, what's his name, and he invented television, and we think of him more as an engineer, not a physicist.
Radar, microwave.
Radar, microwave. We think that is more engineering jobs.
Not to mention MRI scans, PET scans, X-rays. In other words, almost everything you see in your living room.
We disagree. I disagree with that. Those development of those things are sort of more engineering tasks. Theoretical physicists might have come up with some idea, and that gets put to some practical use, but that is more engineering.
Almost everything you see in a modern hospital at some point or other can be traced to a physicist.
I disagree. You suddenly, I think one of the greatest scientists of all time was Tesla, but I don't think he was really a physicist. He was more an engineer, and he's invented the AC power grid and things like that, and those are inventions. You're thinking of they're inventors. They're not necessarily going to be physicists, and if you're going to call them physicists, you're going to sort of like backstepping and calling them something what they were probably not in their lifetime. I don't think Tesla was a physicist. I think he was an inventor or electrical engineer or things like that, but wasn't a theoretical physicist, so it's his total misrepresentation.
Now, I got interested in physics when I was a child. When I was 8, a great scientist had just died. I still remember my elementary school teacher coming into the room and announcing that the greatest scientist of our era has just passed away. And that day, every newspaper published a picture of his desk, the desk of Albert Einstein. And the caption said, I'll never forget, the unfinished manuscript of the greatest work of the greatest scientist of our time. And I said to myself, why couldn't he finish it? I mean, what's so hard? It's a homework problem, right? Why didn't he ask his mother? Why can't he finish this problem? So as a child of 8, I decided to find out what was this problem. Years later, I began to realize that it was the theory of everything.
So that's what he did. Similar situation to me. I was interested in what Einstein was working on, so I decided to find out what unified field theory he was working on, and I found out it was Boscovich's theory. If I go down, so I have looked at this issue of the unified field theory, in the way I write it here. So I've looked at this issue, and the unified theory of Newtonian physics is Boscovich's theory, and this is omitted from physics education. Boscovich's theory is the unified field theory, and that is what Einstein is working upon. So I've looked at this issue of what Einstein was working on, and the unified field theory is working on Boscovich's theory. So it's omitted from physics education. From my point of view, that theory makes sense, and theorists have gone wrong with Einstein. So what Einstein is famously known for is not being able to come up with a unified field theory. But the unified field theory that he was working from was Boscovich's theory. Just he came up with lots of things that were wrong. Einstein was wrong a lot, so he wasn't able to work out what to do with Boscovich's theory, but he was still working from Boscovich's theory, and that is the unified field theory. So that's where I come from. Next.
The unified field theory. An
Boscovich's
equation
theory.
that would summarize all the physical forces in the universe. An equation like E equals mc squared.
You've got all the forces of the universe dealt with in the theory of Boscovich's theory. It's unified field theory.
That equation is half an inch long, and that equation unlocks the secret of the stars. Why do the stars shine? Why does the galaxy light up? Why do we have energy on the Earth? But then there was another thing that happened to me when I was around 8 years old. I got hooked on the Saturday morning TV shows, in particular, Flash Gordon. And I was hooked. I mean, every Saturday morning, watching programs about aliens from outer space, starships, ray guns, invisibility shields, cities in the sky. That was for me. But after a few years, I began to notice something. First of all, I began to notice that, well, I didn't have blonde hair and blue eyes. I didn't have muscles like Flash Gordon. But it was a scientist who made the series work. In particular, a physicist. He was the one who discovered the ray gun, the starships. He was the one who created the invisibility shield. And then I realized something else. If you want to understand the future, you have to understand physics. Physics is at the foundation of all the gadgetry, the wizardry, all the marvels of the technological age. All of it can be traced to the work of a physicist.
And from our point of view of the distance, who are mainly engineers, we look at theoretical physicists and we think they've gone wrong. They've gone wrong with Einstein, so their understanding of their technology is wrong. We think the technology is more due to inventors, due to engineers and so forth, who are putting things to practical use, and people like theoretical physicists have gone wrong now with Einstein.
Most of science fiction is, in fact, well within the laws of physics, but possible within maybe 100 years. And then we have impossibilities that may take 1,000 years or more. That includes time travel, warp drive, higher dimension.
They're going off into fantasy now. It's the track that Einstein's putting them onto. Well, Einstein's always wonderful ideas, and suddenly they're going off onto these things like warp space drive and all that sort of thing.
Portals through space and time, stargates, wormholes.
All fantastic stuff.
You know, if you were to meet your great-grandparents of the year 1900, they were dirt farmers back then. They didn't live much beyond the age of 40 on average. Long-distance communication in the year 1900 was yelling at your neighbor. And yet, if they could see you now with iPads and iPods and satellites and GPS and laser beams, how would they view you? They would view you as a wizard or sorcerer. However, if we can now meet our grandkids of the year 2100, how would we view them? We would view them as gods, like in Greek mythology. Zeus could control objects around him by pure thought, materialize objects just by thinking. And their perks being a Greek god, Venus had a perfect body, a timeless body, and we are beginning now to unravel the genetics at the molecular level of the aging process. And then Apollo, he had a chariot that he could ride across the heavens. We will finally have that flying car that we...
All this is really diversion. It's kind of like, if you want to be a theoretical physicist, you just want to go off into dreamland. It's not getting down to practical issues. Engineers more concerned with practical things.
We've always wanted to have in our garage. By the year 2100, we will have the power of the gods. To paraphrase Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from divinity. So let's now begin our story. The history of physics is the history of modern civilization. Before Isaac Newton, before Galileo, we were shrouded with the mysteries of superstition. People believed in all sorts of different kinds of spirits and demons. What made the planets move? Why do things interact with other things? It was a mystery. So back in the Middle Ages, for example, people read the works of Aristotle. And Aristotle asked the question, why do objects move toward the earth? And that's because, he said, objects yearn to be united with the earth. And why do objects slow down when you put them in motion? Objects in motion slow down because they get tired. These are the works of Aristotle, which held sway for almost 2,000 years until the beginning of modern physics with Galileo and Isaac Newton. When the ancients looked at the sky was full of mystery and wonder. And in the year 1066, the most important date on the British calendar, there was a comet which sailed over the battlefield of Hastings. It frightened the troops of King Harold, and a young man from Normandy swept into England and defeated King Harold at the Battle of Hastings, creating the modern British monarchy. But the question is, where did the comet come from? What was this comet that mysteriously paved the way for the coming of the British monarchy? Well, believe it or not, that same comet, the very same comet that initiated the British monarchy, sailed over London once again in 1682. This time, everyone was asking the question, where do comets come from? Do they signal the death of the king? Why do we have messengers from the heavens in the sky? Well, one man dared to penetrate the secrets of comets, and that was Isaac Newton. In fact, when Isaac Newton was only 23 years old, he stumbled upon the universal force of gravitation. According to one story, he was walking on his estate in Woolsthorpe, and he saw an apple fall. And then Isaac Newton saw the moon. And then he asked the key question which helped to unlock the heavens. If apples fall, does the moon also fall? And the answer was yes. And that answer overturned thousands of years.
What we got really is the apple is affected by gravity, and so is the moon. So we've got a unification there of the motion in the heavens and the motion on the earth. And the story about the apple falling, that's probably allegorical. It's probably not really happened. But anyway.
Of mystery and speculation about the motions of the heavens. The moon is in free fall. Just like an apple, the moon is constantly falling toward the earth. It doesn't hit the earth because it spins around the earth and the earth is round.
I think he's got it wrong when they finding out that the moon is actually moving away from the earth. But it's a very small effect.
But it's acting under a force of gravity. So Newton immediately tried to work out the mathematics, and he realized that the mathematics of the 1600s was not sufficient to work out the motion of a falling moon. So what did Isaac Newton do? When he was 23 years old, not only did he stumble upon the force of gravity, but he also created calculus. In fact, he created calculus at the rate at which you learn it when you're a freshman in college. And why did he create calculus? To calculate the motion of a falling moon. The mathematics of his age was incapable of calculating the trajectories of objects moving under an inverse square force field. And that's what Isaac Newton did. He worked out the motion of the moon. And then he realized that if he understands the moon, he also understands the motion of the planets in the sky.
Ideally, at freshman physics, you should be learning all this Newtonian physics when you find it really hard here in physics.
Solar system. And Isaac Newton invented a new telescope. It was the reflecting telescope, and he was tracking the motion of this comet. Well, it turns out that everyone was talking about the comet, including a rather wealthy Englishman by the name of Edmund Halley. So Edmund Halley, being a wealthy merchant, decided to make a trip to Cambridge to talk to England's illustrious scientist, Sir Isaac Newton. Well, Edmund Halley asked Newton, "What do you make of this comet?" No one understands comets. They're a mystery. They've been fascinating people for centuries, for millennia. What are your thoughts? And then, I paraphrase, but Isaac Newton said something like this. He said, "Oh, that's easy. That comet is moving in a perfect ellipse. It's moving in an inverse square force field. I've been tracking it every day with my reflecting telescope, and the path of that comet conforms to my mathematics exactly." And of course, we don't know what Edmund Halley's reaction was, but I paraphrase. He must have said something like this: "For God's sake, man, why don't you publish the greatest work in all of scientific history? If correct, you have decoded the secret of the stars, the secret of the heavens. Nobody understands where comets come from." And then Newton responded and said, "Oh, well, it costs too much. I mean, I'm not a wealthy man. It would cost too much to summarize this calculus that I've invented and to work out all the motion of the stars." And then Halley must have said this: "Mr. Newton, I am a wealthy man. I have made my fortune in commerce. I will pay for the publication of the greatest scientific work in any language."
The trouble with all this story is how much of it is accurate, and I think he's just making it up, really. It's if you try to stick to the hard facts, it's not a very interesting story as he's making it out to be. Greatest book in science. You might not have probably used that words at that time.
And then Halley must have said this: "Mr. Newton, I am a wealthy man. I have made my fortune in commerce.
Probably all
I
made
will
up this.
pay for the publication of the greatest scientific work in any language." And it was Principia. The principles, the mathematical principles that guide the heavens. Believe it.
So that is the greatest work in physics, Newton's Principia, where he laid the foundations for Newtonian physics. And ideally, at freshman physics, that is what is being taught.
Or not, this is perhaps one of the most important works ever written by.
So, according to this physicist's point of view, it's one of the most important works ever written.
A human being in the 100,000 years since we evolved from Africa. Realize that this book sets into motion a physics of the universe. Forces that control the motion of the planets. Forces which can be calculated. Forces which govern the motion of cannonballs, rockets, pebbles, everything that moves. moves according to the laws of motion and the calculus of Sir Isaac Newton. In fact, even today, when we launch our space probes, we don't use Einstein's equations. They only apply when you get near the speed of light.
So he's going wrong now. He's talking about black holes, and if I refer you to my other videos, we've got people like Crothers, and they're pointing out what Einstein's dealing with black holes is a load of nonsense, really. It's quite a mess. So we go back to it. The most important book in physics, if you can find it again. There. The most important book in physics is the Principia by Isaac Newton. Now, the second most important book is this one, and it's too dark for me to see it. I shall turn the light on. This is the second most important book. A Theory of Natural Philosophy by Roger Boscovich. It's a theory of natural philosophy, and this translation of the book makes it accessible to the historian and philosopher of science. It's the magnus opus of Roger Boscovich. And this book continues to deal with Newtonian physics. It's a continuation of Newtonian physics, and it provides a unified theory of Newtonian physics. This is the next step on in Newtonian physics. So if we go back to here, to my notes, the unified theory of Newtonian physics is Boscovich's theory. That one. And it's omitted from physics education. So they start off their freshman years, they teach them Newtonian physics, they deal with the Principia of Newton, and they don't actually get on to dealing with the unified theory of Newtonian physics. That's where they go wrong. So this is why we get this stereotype. This is the stereotype of why the physicist versus the engineer issue. From the physicist point of view, they consider themselves superior to engineers. They have carried on from freshman physics, which was dealing with Newtonian physics, to deal with all the Einstein stuff. And the engineers, they've concentrated on Newtonian physics. And when they look across to the physicist, well, the physicist dealing with all the Einstein stuff, that seems nonsense. And that's why our group is growing. Our group is growing because we are more committed to Newton. Our growing group is more committed to Newton than we are to Einstein. When we look at Einstein, we say Einstein is wrong. We are a group mainly of engineers, go by Newtonian physics, and when we get to look at Einstein from our background, we say Einstein is talking nonsense. And Michio Kaku has revealed why they have gone off into a fantasy. They've gone off into a fantasy, these physicists have gone off into a fantasy with Einstein, and they've gone completely wrong. Thank you.